Okay, to begin with, today it's about using your calculator to do application problems with matrices. And to begin with, I've just started by doing a problem with the guys here where they were multiplying matrices that had variables in them. And I warned them that that kind of stuff is on the test because we will allow calculators on the test. So that's why we have to put variables in the problem to test if they know how to do it without the calculator. All right, let's move on to here. We've got this blue slide. Everybody get there, please. You see this system of equation that's in dark blue there? That system of equation is the typical kind of problem for today, and we got to learn how to solve that kind of problem. I gave you a little pre-teaching on this, so that it shouldn't be that bad. All right, if I have two matrices, like for instance, everybody write these down. 2, 3, 4, 5 times xy equals 10, 15. First of all, let's see if that even makes sense. This is a 2 by 2, right? This is a 2 by 1. Do they match up? Do they work? Yes, and they make a 2 by 1 matrix. This is a 2 by 1 matrix. Now, I think in the example problem I used the other day, this answer matrix wasn't even correct, but that doesn't matter because we never actually even solved the problem. I just told you generally how you'd solve it. Do you remember hearing that if we took the inverse of this matrix and multiplied it, that would make it go away? There's little voices in the hallway. Apparently, the 8th graders must be here to visit at the high school. Oh, I'm sorry. Okay, anyway, so this is matrix A. You're going to put that in your calculator. Everybody grab your calculator, type that in as matrix A. And I'll pause for a second while we get ready. Okay, so here's how you do the matrix on your calculator. You go to second matrix. It's right above the x to the negative 1 key, the inverse key. And I'm going to go edit. That's the most common mistake, is to forget to arrow over to edit. And I'm going to edit my first matrix. And I want it to be a 2 by 2. I've already got those numbers in there, but I'd be typing a 2 and a 2. And then I'd type in 2, 3, 4, and 5. That's my matrix A. Now, of course, if we have a matrix A, that begs the question, do we have a matrix B in this problem, do you think? Well, you can't put in an X and a Y as matrix B. You're not allowed to put in variables into a matrix. But there is this matrix. Let's call that matrix matrix B. So everybody put that into your calculator. It's a 2 by 1 matrix. So I'm going to quit out. I'm going to edit. I'm going to go back into the matrix thing and go over to edit, and I'm going to edit B. Okay, and I'm going to edit B and make it a 2 by 1. And I've got a 2 by 1, and my numbers I want there are 10 and 15. All right, so now that I've got those numbers in there, I've got matrix A and matrix B all done. I'm going to quit out. Now, do you remember to solve this thing, I got to get rid of this matrix right here. What will get rid of it? The inverse of it. So I need to do A inverse on this side and A inverse on that side. It's important to understand that you cannot put the A inverse behind it. Remember that the order matters? If I do B times A inverse, it's different than A inverse times B. The inverse has to be on the left. Okay, do you get that? So now, do I really need to type in this matrix times this matrix? No, because I know it's just going to disappear anyway. Know what I mean? It's going to cancel. So there's no need to do that. But what do I end up needing to do? Inverse of A times B. So everybody on your calculator, get the inverse of A up there. First you got to get A up there. It's under matrix. Just put an A out on the screen. If you're not with me, get with me. You got to get this done because I'm going to be out there checking your calculators in a minute. All right, A, and then inverse, and then times B. And it looks like that, and it's all ready to go. I don't have to hit enter until I know that I've got it right. A inverse times B. If you set up all your problems like this, that's all you're going to do every time. Do the inverse of A and times it by B. All right, so I hit enter. Final answer is negative 2.55. What does that mean? That means X is negative 2.5 and Y is 5. Show me that on your calculator. Hold it out to me as I walk past. Something is wrong in one of your matrices. Fix your matrix. You're good. You're good. You're good. Just a second. Let me pause my recording. All right. So let's move on to solving one that's a little more difficult. I do want to take just a second to talk about these important words down here. They are going to ask you on a test to make a variable matrix. Guess what? That's just this. Then they're going to ask you to make a coefficient matrix. That was this matrix, the one with all the numbers in it that you pulled out of the equation. That's a coefficient matrix. And then the last one is a constant. Constant means it doesn't ever have a letter on it. A constant matrix is that guy right there. You should also remember that the identity matrix for a 2 by 2 was this, 1, 0, 0, 1. Do you remember that? That was the identity matrix for a 2 by 2. If it's a 3 by 3 matrix, it would look like this. Remember that one where the ones run down the middle? Those are called the identity matrices. They're kind of like a 1. So if you ever want to keep something's identity, you multiply it by this, and it'll keep its identity. All right, so that's a review of the stuff we've done so far. Now, original system. That's given to you in a lot of problems, and you got to type it in to a calculator like this, though. How does it get from here to here? You have to be able to arrange it. You pull the numbers out, the constants, or sorry, the coefficients, they come off of here, 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 and here. Those 4 numbers go down in here. The X and the Y just make a little matrix, and then the 5 and the 13, those are the constants. See, they came from here. So it's not that hard to make one of these. I'd like you to try to make one of those for this. Get to the blue page. You're making a little deal where this part will have the coefficients in it, this part will have the X and the Y in it, and this part will have the constants in it. If you don't understand what I'm talking about, you'll see in a moment. But the first one is a 2 by 2 matrix that has 4 numbers in it. Try to figure it out. A number here, 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 and here. And then this is my variable matrix. And then this last one is my constant matrix. You don't have to put this in the calculator yet. All I have to do is make it. All right, you should have used a 1 for that because there was no number there, but there's a 1 there. There's a -3 right there. This one's a 2, and this one's a 5. Raise your hand if you had that right. Good. Then you should have had an X and a Y, and that's like the easy part. And then the last thing is the 4 and the -3. That wasn't that hard, was it? Then this is A, this is B, and in the end, you're going to have to do what to both sides? Multiply by the inverse of A. And does it matter which side you do it on? Yes. Go ahead. Enter it. Solve it. Pause for a second while you do that. Okay, so you put this in as matrix A, and then you put that in as matrix B, and then what you really needed to do was this part, the part where we multiply inverse of A times B. What did you get? 1, -1. Raise your hand if you got the same thing. Okay, awesome. Then you're doing them right. Now let's get on to the more important stuff, and that is how to not only like write down a system, but how to get it from words in a word problem into equations, which you can then put into matrices, okay? This is basically the same thing. We'll go to the yellow slide, the one that's got the basically triple X, Y, and Z kind of problems. I do want to make sure you know how to set this up. Set up one of these for me for this problem. Let's see if you can do it. Put all your coefficients in here. Coefficients are numbers that are on the variables. For instance, this is 3, 2, 4 across the bottom. Put your variables in the next one, and the last matrix there is just for the constants. Okay, here's what you should have had. 1, 1, 4, 0. How many knew put a 0 there? Good. 2, 5, and then the 3, 2, 4 that we already had. Okay, now we need an x, a y, and a z. And then last, we need those three numbers, 2, 4, and negative 7. It's not that hard, is it? Then, this is matrix A, this is matrix B. What you really need to do is take inverse A and multiply it on both sides, but don't do it on the wrong side by accident. Inverse of A has to be first, and then times it by B. Final answer. What'd you get? Anybody actually done? What'd you get? You are correct. All right, I think from there you'd have no trouble getting this puppy done. The hard part is writing the equations. All right, and then the really hard part is to actually, I'm skipping over this other way. I found that since we're having the test fairly soon, if I teach you another way to do it, you might just get the two ways confused with each other. So if you, in case anybody talks about this reduced row echelon form, it's just another way to solve those, but it's completely different. And I don't want to confuse you with it because you don't need to know that way of solving them. Instead of doing reduced row echelon form, I'd like to talk through some of the word problems on your homework. So everybody find your homework that we are assigning today. It's called Matrices Day 4. And I've got some good news. We are skipping several problems. You're going to skip problems 3, 4, 5, and 6. Because I feel like you are good at putting them into the calculator. So we'll just do 2 of that kind. So you may skip 3, 4, 5, and 6. That'll save a lot of probably unnecessary typing of numbers in the matrices. And instead, we're not doing any extra problems, but instead we'll spend more time in class here talking about how to do the word problems. Okay, so I'll pause for a second while we pull those word problems up. Okay, so we're skipping problems 3, 4, 5, and 6 there. So 1 and 2 will be plenty of practice for solving those where they give you the equation. This is the harder part. We have to actually write the equations first, then we got to put them into a matrix, and then we got to put them in the calculator, and then you have to actually do the right thing to solve it. So, the school that Lisa goes to is selling tickets to the annual talent show. So far, they haven't told us anything that actually matters for an equation. On the first day of ticket sales, the school sold 4 senior citizen tickets and 5 student tickets. All right. Well, we better start by picking what X and Y are going to be, right? I would recommend that the first thing that shows up, in this case it's senior citizen tickets, should be X. X is going to be senior citizen tickets. Y is going to be student. All right, so if they sold 4 senior citizens tickets plus, it's 4 X's plus 5 student tickets, that's 5 Y's, what did they get? $102. Again, some of you might be thinking, but don't we have to know how much the tickets are? That's the point. They haven't told us how much the tickets cost. That's what we're going to figure out. They told us how many tickets we had. We did other problems like this where they wouldn't tell us how many tickets we had, but they would tell us the price of the tickets. This time they're telling us how many tickets we have, but they're not telling us the price. We are supposed to solve for the price. Okay, so there's one equation. The next line gives us another one. Try to do this without me. The school took in 126 on the second day by selling 7 and 5. Now notice, your equation needs to be written with the X first, then the Y, and then the total. I know it's not given to you that way, but that's the way you need to write it so that it matches up. You know what I mean? If you start with 126 equals blah, 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 these numbers aren't going to line up nice, and you won't be able to put them in matrix nice. All right, so this is 126 then. And it was 7 X's plus 5 Y's. Cool. Now, your job here is set up a system of equations, put it in a matrix, and solve for each problem. Could we solve it another way? Yes, there's an algebra way we could solve it, but the point here is to teach you how to use matrices. So let's get these things put into a matrix. Do you get that the matrix would be 4, 5, 7, 5, and then x, y, and then 102, 126? Because on your test, we are testing that you can write the equation too. Don't just jump right into putting it in the calculator. You have to know how to write that equation. So if you haven't already, it does say in the directions, set up a system of equations. That's this part. I guess it doesn't ever say you have to do this, but I'm telling you, I'm warning you, you need to know how to write that little thing I wrote in black. That part's required. This is called the coefficient matrix. This is called the variable matrix, and this is called the constant matrix. And then if you type them all in right, you do that inverse A times B deal. If this is A and this is B, you want to do the inverse A on both sides to cancel that off. Inverse A times B, what did you get? Somebody already have them? Got 8 and 14? Can anybody verify that? Several people. Good. All right. I just wanted to show you one of those on the video for today. And obviously we do have work shown and stuff on the key, so you can always use that as well. And that is all I've got for you for today.